Consider the matrix A13, 1B1, 311, where A comma B greater than or equal to 0. If minus 2, 3, 6 are three eigenvalues of the matrix, then what are the values of A and B? Here in this question, a 3 by 3 matrix is given along with the eigenvalues. Here we have to find terms A and B in the matrix. In matrices, we have a property that sum of the eigenvalues is equal to trace of the matrix. Sum of the eigenvalues is equal to trace of the matrix, and product of the eigenvalues is equal to determinant of the matrix. So if we see options here, trace of the matrix is nothing but sum of the principal diagonal elements. So here sum of the principal diagonal elements is A plus B plus 1. So if we see options, here A plus B, in the options A plus B is, in option A plus B is 6, 6 plus 1, 7, and the sum of the given eigenvalues is also 7. So there is a chance for option A. If you see option B, A plus B is 6. So we even have choice for option B. If you see option C, we can eliminate option C. Why? Because here sum of A and B is 5 and 5 plus 1 is 6. So trace of the matrix is 6, but sum of the eigenvalues is 7. So we can eliminate option C. If we see option D, sum of A plus B is 7, and 7 plus 1 is 8. Here trace of the matrix is becoming 8, but here sum of eigenvalues is 7. So we can eliminate even option D. So there is chance for option A and option B. So now let us check with this property, second property. Product of the eigenvalues must be equal to determinant of the matrix. So here product of the eigenvalues is 6 3s are 18. 18 into minus 2 minus 36. So determinant should be minus 36. Now let us substitute A and B as 1 and 5 in the matrix. So if we substitute 1 and 5 in place of A and B, the matrix will be 1 1 3 1 5 1 and 3 1 1. So if we find the determinant, 1 into 5 minus 1 minus 1 into 1 minus 3 plus 3 into 1 minus 15. So this is 4 minus this is minus 2, so plus 2. This will be minus 42. So determinant will become minus 36. So for option B, sum of the eigenvalues is becoming trace of the matrix, and the product of the eigenvalues is becoming determinant of the matrix. So here option B is the correct option.
Following is true. Here R indicates regular, CFL indicates context free, HP indicates halting problem, RC indicates recursive. So actually this diagram is given, that means R is regular, then R is subset of CFL is subset of halting problem is subset of recursive, like that. Okay, this is just like the hierarchy of formal languages. There is one hierarchy, that is Chomsky hierarchy, where regular language is subset of context free language, is subset of context sensitive language, is subset of recursive, where recursive language is subset of recursive enumerable. Here recursive enumerable is undecidable. Halting problem is also undecidable. That means halting problem is it is recursive enumerable. Okay, that's why recursive is subset of CFL is subset of recursive. Regular is subset of CFL is subset of recursive. Recursive is subset of recursive enumerable, where HB indicates recursive enumerable. Option D is the right option.
Consider the following grammar.
S2AB, A2A, A2BAB, B2BBA. Which of the following is false? The length of every string produced by the grammar is even. And then option B is no string produced by the grammar has 4 consecutive B's. No string produced by the grammar has 3 consecutive A's. D, none of these. Here the length of every option A is correct, because the length of every string produced by the grammar is even. Because if you take any string like S2AB, so if you take A2 small a, B2 something like BBA, then again you have to terminate A with small a, so you will get the length 4. So like this, any string you take, even length only you will get. Next option B is no string produced by the grammar has 4 consecutive B's. Say let us take one particular. So S2AB, again A2 small a, B2 BAB, again B2, you can take BBA, okay, again we can take B2 BBA, again A2, this A2 if you take BAB, then 4 consecutive is definitely you get. Okay, but no string produced by the grammar has 4 consecutive. This is wrong. So this is a false statement. Option B is the right option. Whose size is 128 kilobytes, block size is 32 bytes, and the catch is 4-way set associative. If the physical address contains 32 bits, then the number of bits required for tag, index, block, offset respectively. So here the catch, can divide this into tag and the index block. So this will be total number of bits required here is 32 bits, because the physical address is given as 32 bits. So what is the size of the catch? 128 kilobytes. 128 kilobytes is equal to 2 power 17. Okay. So if it is 4-way set associative, we require 2 power 2. That means 2 bits are required. Okay, 2 bits are required. Then 2 power 5 byte, 32 bits are there, no? Then 32 bits means 5 bytes. Okay, so 2 power, the physical address contains 32 bits, and block size is 32 bytes. 32 byte means it is 2 power 5. 2 power 5 byte blocks. That means, so we can have 15 minus 5, where 5 is the number of bits we use for the block, and 15 is the number of bits we use for the tag. Okay, so now that is a total tag initially before dividing into sets. Okay, 15 minus 5, you will having 10 bits. So for the tag we will have total 17 bits, that is, and then 10 is the blocks, number of blocks will be 10, and in each block will have 5 bits. So that is this 17, out of the 17 bits, 32 minus 17, it is around 15 bits. Okay, in this 2 bits we used to take from the block portion, the catch portion, so it will become 17 tag, 10 blocks, number of blocks 2 power 10, so 10 bits, and offset of the block is 5 bits. Option A is the right option.
Which of the following statements is true? Statement 1, static allocation lays out storage for all the data objects at compile time. Stack allocation manages, second statement is stack allocation manages the runtime storage as a stack. Option A, only 1, only 2. Option B, option C, both 1 and 2. Option D, none of these. Here both the given statements are true. So your correct option is option C, which is both 1 and 2.